Welcome, everyone. This is now our sixth or seventh monthly demo series. My name is Jonathan Gill. I'm the head of business development. I'm going to be your host and guide through your inside look at Aisera, and today, specifically IT and AI ops. Joining me today is going to be Jant and Kay. They're going to be your main resource for all things platform capabilities, and Joanna, who's actually going to support with all of our engagement. Um, we're going to give you a peek under the hood. We're going to showcase a few topics today. We're going to deliver a single universal agent experience with automated incident resolution or remediation. So that's first. Second, we're going to help how we predict and resolve major IT issues before they even impact the business. And lastly, correlation across data sources with filtering and deduplication. Before I know, as we work through this session today, please feel free to drop notes within the chat. We want to make this as collaborative as possible. Joanna will be my partner and continue to monitor all of these, and we're going to facilitate questions in real time. Kay has done this before, so it's going to be nice and fluid. Joanna, thank you so much for joining us. As we get started, we're excited to have you all here. So thank you all. I want to pass it off to our team members, Jan and Kay.
All right, well, I'm going to kick things off here. Welcome, everyone. And we're going to start the focus of the demonstration today is going to be AI ops and everything that Jonathan just walked through. And as we go through this conversation, I'd like you to think about these four main concepts. Agentic AI is now no longer a new phrase, a new term. It's all over the market. And agentic AI is succeeding or failing based on one thing, and that's adoption. And adoption drives usage. Usage is what drives ROI. So it's hard to measure the ROI of your AI initiatives if they're not being adopted. And so I really want you to think about in this conversation is how Aisera is helping organizations adopt agentic AI. And the results we're seeing of our customers being able to have better results because of these four concepts. And the big one that Giant is going to spend a majority of his time talking about are these multi-step actions. And in that use case, we're really going to be focusing and drilling into AI ops. But what I want you to think of, as a bigger, broader perspective, is that these agents, these agentic agents, these virtual agents that are now becoming a part of your team, whether that's to help your customers or your employees across your organization be more efficient, these agents, they can work in multiple areas. And the challenge with adoption with a lot of organizations is you've got these agents popping up and your users don't know where to go for help. Now, all I know as a user is that I need help. So I want a universal approach. I want somewhere that I can go one place where I'm naturally spending my time so that I can get this help so that this AI can be adopted. And that's the concept of our universal agent. And I'm going to showcase that. And the other two concepts to think about as we go through is rapid time to value. If you can't get these initiatives kicked off quickly, they're not going to succeed. And with Aisera's concept of a no-code flow automation, which it's a lot of words there, but that essentially is a way to leverage large language models and APIs to be able to very quickly build up these agents. And Giant's going to showcase a bit of that capability. It's called Hyperflows. It's an Aisera coined term, but the idea is again just making these quick for a business user who understands the logic of their business to be able to with natural language build these out, and that's that rapid time to value. And then these agents are continuously learning. Leverage this AI, leverage our concept of RAG to incorporate your documentation, meet your data sources where they are, and then have these agents continually be trained. That's the concept of continuous learning. Now, in terms of the universal agent and some of the demonstration piece that I'm going to showcase here, these agents, the Aisera universal agent can be an orchestration across whatever automations you've incorporated already in your environment. And so in those agents can sit in Microsoft Teams. Here's an example of an Aisera Assistant that is doing software provisioning, right? That this same Aisera Assistant can answer questions on PTO balances, benefits for HR, and your Aisera, your AIOps requests as well that Giant's going to take you through. So that's this concept of universal agent. Universal agent can sit in Slack and listen for those conversations where it can help and be a listener. It can also sit within your intranet site. You could set up a what we call, Copilot is such an overused phrase. You can call this whatever you want. You can customize these to match your intranet look and feel. But these HTML pages allow you to preload use cases, things like, again, more of a implementation with Workday or an HR tool within your organization to be able to update an address. All things that your employees need to do, and it requires time to update these, that they can do from a natural conversation in within where they're used to being. So that universal approach. So that's all I really wanted to cover was that, again, our core values of accelerating AI adoption and then focusing in on that universal approach. I'm going to let Giant dive into AI ops here, and I appreciate your time, and we're here, so ask questions. I can dive into any of these concepts deeper after we go through some of these AI ops use cases, but I'll turn it over to Giant now.
Sure. Thanks, Kate.
Mhm.
So let's get started. All right. So let me see if you guys can see my screen.
Good to go.
Yep.
All right. Okay. So before we go into the details of it, I just want to lay over the perspective what we are going to talk about in the next hour and a half. So if you take a look here, the in the AI ops use cases, what we essentially want to do is we want to bring observability and agenticity across your applications, right? These can be AI applications, these can be your infrastructure or anything else. To do that, what we want to do is we want to provide you early warnings related to performance, related to user experience issues, related to outages, and those kind of things. After we give you early warnings, we want to go to the next level and we want to provide you an impact and a root cause analysis, right? That, hey, if some outage has happened or some incident has happened, what was the impact of it and what was the root cause of it? Once you have identified the root cause and impact of it, you would want to resolve it. So that's where what Kay was showing you just now, right? So we have the universal assistant, which can work for IT ops, for your SREs, for your DevOps teams. On the top of it, the way we want to do it is we want to enrich your CMDB data, right? So every company has in one form or another their CMDB. So we want to make sure that the CMDB stays healthy, the CMDB relationships are right, and they are becoming dynamic, right? And the reason why we want to do it or we can do it is because we want to have uh, visibility across your ecosystem. So we want to hook in into your observability platforms. We want to hook in your ITSM platforms. We want to hook in into your logging systems. And we want to continuously capture data from there and do it, right? And then on the top of it, there are specific use cases where we want to do your change management risk advisory. If a specific pattern of changes has a history of failure more than others, and next time that change comes, we want to proactively identify and say that, hey, this is a risky change. You better take care of it. Do you have a backup plan for it? And that sort of stuff. And on the same lines, we want to do asset management and capacity management as well. On a high level, this is what we are going to talk about here. So now the question comes how? So the question of how comes is that across your infrastructure and application, every component requires some kind of observability and predictability. Observability we have captured in some capacity or other. There are already monitoring tools which are providing you observability around it. uh, we want to provide the predictions around it, right? So if your network is fluctuating, we want to see that how that historical behavior of that specific switches, or if your infrastructure is running out of CPU, you want to make sure that it doesn't cross a specific threshold. So there can be multiple use cases where you want to apply observability. How do we do it? So if in current market, if not in all the places, we have fragmented tools which are being used across organizations, right? So you might have your network performance monitoring tools, you have your infrastructure monitoring, you have your log monitoring, application monitoring, text monitoring. These all different tools, as long as they work in silos, they provide you one single problem and you can probably solve it. What we want to do is, sorry. what we want to do is we want to sit in the center of all your observability plus ITSM tool, which is not there. We want to connect to your 40 monitors, to your uh, data dogs and Splunk and Elastic and everywhere else we want to we can capture data for your infrastructure and application. And once we collect this data, what we want to do is we want to collect this data from all these different tools. They can be your monitoring system, they can be your data lake systems as well for that sake. And we take the data, we have our AIOps pipeline, which processes it. On the left-hand side, we also take your ITSM data as well. We want to see, hey, that what changes have you have filed, what problems have been created, what incidents have been filed. Aisera takes all that data into a centralized platform and something which Aisera generates is what we call AMIs, Aisera Major Issues. Now, these AMIs essentially talks about what is the percentage of a specific pattern becoming an outage, what is the percentage of this becoming a major issue in future. We talk about all those kind of things, and we will talk about it in detail about all this, right? So that's what essentially on a higher level we want to do. We want to hook it into your all your observability and ITSM and your logging platform, process the data, be agentic about it, use some machine learning concepts as well for that sake if we need, and then we start producing outages and major incident predictions.
Giant,
Hey,
if you don't mind taking a quick pause, we do have a question from the audience.
sure.
Uh, Joel Roberts has asked, how do you use our data to improve the development of the tools while at the same time protecting our data?
Uh, so I'll answer the second question first. So how do we protect your data, right? So there, Isera is very, we have a very security intensive pipeline. So we take care of your data. Uh, we encrypt your data while it is at rest versus while it is at motion. We have PII masking enabled at any layer, right? So even we can encrypt data while we are making API calls to ingest it, and after even we have ingested, we can use PIA masking. We can mask your credit card numbers, your UN numbers, or anything, driving license numbers. Those can be masked automatically, and there is a whole science behind it. But on a higher level, that is one way by how we protect the data, right? We have your data residency policies versus data retention policies, which all can be defined, and we want to be transparent about your data. So you whatever data you have, you can see what has been ingested, what it has been shared with, and the tenant which you get is very specific to your environment, so your data will not be shared anywhere. Possibly that answers some of the questions, but the security is a deeper thing, so I'm going to leave it there. If there are further questions, I'll clarify it. Now I'll come to the first question, right? That how do we improve your developer performance? So at various levels actually. So starting with the noise reduction itself. Now, if today you have a Splunk or Datadog or anything else, you might be flooded with a lot of alert. And what essentially happens is that you become immune to those alerts. That hey, I am every day getting high CPU utilization alerts, or I'm getting disk usage alerts, but because there is no outage, you don't care what is exactly happening there, right? The same cases with the incidents as well, or the problems as well, right? So what we want to do is we want to reduce the noise, and we want to make sure that only when a specific pattern cross very specific thresholds, only then we want to notify you and say that hey, historically whenever your CPU utilization has been around 80%, this hasn't caused into outage, but today I'm seeing that outage going beyond 85%. So that's one way of how we reduce noise and make your alerts or observability data actionable. The second point is that we don't want to look at data in the silos itself. We want to see that hey, if something is happening at your infrastructure layer, what is happening at your DB layer versus your network layer, what is versus your application layer. So you no longer are seeing only high CPU utilization alerts versus disk usage alerts versus machine down alerts. You are seeing that hey, because this machine was down, because of this specific business application was impacted. So that way, we are quantifying the value of an alert from a developer perspective. Uh, Again, 2 points. Another point can be we are predictive about it, and we are a reinforcement learning based algorithm. So you can fine tune the system to according to your needs. If you like, if you want to give value to specific patterns, you can give positive feedback to the system. And if you want to discard some of the negative things which you know that they are not useful, you can provide negative feedback as well. So on a high level, that's how we deal with developer productivity. Uh, Hope that answers the question.
Thank you for that. And yeah, if anyone else has other questions, if you have follow-up, Joel, please feel free to ask.
All right, so we'll keep going and feel free to interrupt me. I like being interrupted during the demos. So that's how it is, right? So another aspect of it. So after you have identified the issue, you have predicted it, you want to take the remediation part as well. So what ISAR also provides is the workflow-based remediation. These workflow can be agentic, these can be traditional if-else based workflows, wherein we are taking your incident alerts, matrices, traces, configuration changes, and then based on that, we want to take appropriate actions, right? You can have your Ansible playbooks into play. You can have your Terraform scripts. You can have your Jenkins pipelines into play, which you would want to invoke. You might have your shell script. You might have your SCCMs into play, right? So depending on what tool you use, we want to meet you there. And based on the requirement, if you want to use Jenkins for CI/CD pipelines versus Ansible for application automation, the platform supports by default all that. Then another piece, very, very important piece, is the AI discovery and the dynamic inferences of the relationship. So what we want to do is, because we are native to a lot of ITSM and CMDB tools, we want to ingest their data. And because we are uh, but talking to different data sources, right? We are talking to your alerts versus logs and all. We create these dynamically inferences relationship between the CIs, and these dynamic inferences enrich your CMDB. These are the things like, hey, whenever my this X data server is fluctuating, I'm seeing effect on my Y web server. Something which might not be captured into your traditional CMDB, but because of these machine learning algorithms, we see these two things fluctuating at the same time in a time series analysis, if I would call it. And based on that, we create these relationships, and these relationship enrich your CMDB, and they help us predict things better. So next time, if I see any database related issue which is happening, I will automatically go back and see that, hey, what were all the relationships which we created, and then based on that, we do an early detection of the issue. Probably the last slide is the root cause analysis and impact of it. So based on these CIs and more recently through these LLMs, what we also do is we provide you impact and a root cause analysis of it. So these, if when I show you in the demo, these causalities are the causalities between different CIs. So we want to see the whole chain of thought, right? That, hey, because I saw some issues on my DB side, because of that something happened on my web server side, and then that impacted this versus this and this. So whenever your end user or L2 L3 users are coming into picture, they are not starting with a blank slate. They already know that, hey, these are the five top components which could be potential culprits. So you always already get a heads up, and then you can troubleshoot it through our Agentic AI platform, and then you can remediate it and all that. So having said that, those are all the slides which I had. I'm going to take a pause. If there were any questions, I'm going to take that.
It doesn't look like there are any questions, but again, audience, we welcome your engagement. So feel free to ask as Giant goes through the demo.
All right. So starting with very basics. So how do we collect the data here? So this is my Aisera platform. So we have integration and data sources here. So what we do is basically, if you take a look here out of the box, Aisera comes with a variety of integrations across horizons, right? So if I just take a look at the alerting system, you have DataDog to Elastic to Kibana to Splunk to PagerDuty, anything which is emitting alerts, you can get it integrated. The same can be said for your ITSM tools as well, right? So if you are looking at the ticketing system, you have your ServiceNow versus Jira versus anything, right? SolarWinds or Zendesk, whichever way you call it. So the simplicity of the integration is that if you are a ServiceNow user for that sake, you can just simply choose ServiceNow. You can give my service. You can set up a ServiceNow instance. You can provide the endpoint. And all that you need to do is you need to start providing the credentials. And again, we provide a variety of credentials here. Do you want to just provide me a basic or auth, or you want to provide me client credentials? Whatever your needs are, we will meet you there. Once you have set up the credentials, what essentially happens is that we will start setting up the data sources here. Now, if you take a look here, I have the DataDog integration here, but what I want to show you is the ServiceNow part of it because that gets very interesting here. So this is one of my ServiceNow data source here, which I have integrated. In the ServiceNow data source, the couple of things to note here, right? So you will provide a name. The second most important thing is the learning functions of it. So in the ServiceNow itself, I can create multiple data sources. One data source can pull only your changes, incidents, and problems. The second data source can pull your knowledge, and the third data source can pull your CMDB. The fourth data source can, in fact, can pull your service catalogs as well. So that way, you can keep your data ingestion cycle compartmentalized. And then it can be run on demand, it can be run on schedule, or you can customize it. You can provide any cron expression which you feel you want to run it every day once or every day twice, whichever way you want it. You can customize it, and you can provide you pull the historical data of it, right? So for a training purpose of the model, we intend to ingest your 6 months of historical data to train the model to see that, hey, what kind of pattern your historical data had. So that's where it helps. uh, Going further, you can have the custom scripts here. You can enrich your data. uh, Aisera platform by default provides you a deduplication mechanism. So if you want to define an alert signature for your alert, uh, we will deduplicate your alert and reduce the noise at the source itself. So that way, you can set up your ticket ingestion versus you can set up your alert ingestion. Uh, if you take a look here, I have two data sources for the same Datadog, and that is intentional. So the same concept applies for any integration, right? So this is the Datadog integration in which you will use the Datadog external system, that integration, and the rest of the story stays same. So you set up an integration, you set up the learning functions, you set up how often do you want to pull the data, do you want to pull it historically or not, and then you have these configurations which will help you enrich the data. And in the specifically in terms of Datadog integration, you can define your alert signature, which we call fingerprint here. And based on that fingerprint, we will deduplicate the data. If you are receiving 10 CPU utilization alerts, we want to reduce that noise, and we want to make sure that only one alert makes through in those 10 minutes, and we can improve the weightage of that specific alert if the noise is high. Now, just talking about the last thing about the data ingestion, you would notice that I have this Datadog integration as well. So this is a generic connector concept which we have here. Now, what if I don't have an out-of-the-box integration? What do I do? Do I go back to Isera to build it? So the generic integration is the answer of that question, in which you set up a generic integration, and all that you do is you start providing me the endpoints and the authentication mechanism by which any tool which can emit data and I want to integrate with, that can happen here. So as long as you can provide me this JSON, or we can fill up this JSON, you tell me that, hey, this is the endpoint, this is the URI, this is the authentication mechanism, this is how the pagination mechanism works. We can start setting up these data ingestion units on the fly itself. So that way, we meet you where you want us to be. So this can be a pull-based mechanism, or you can set up webhooks on your endpoint and you can start pushing data as well. So if you want your DataDog alerts to be more real time, you can set up a webhook in DataDog, or you can do a pull-based mechanism. Uh, Depending on what kind of data source we have, we tend to mix and match. ServiceNow, we tend to make sure that we pull the data in terms of monitoring system where we want a more live streaming of the data. We tend to go with the webhook mechanism as well. So having said that, after we have collected the data, so what we do after that? So once we have collected the data, you start getting a single pane of glass here, wherein you can see, you can filter the data based on the data source here that, hey, I want to see my ServiceNow tickets versus I want to see my DataDog tickets versus I want to see my Dynatrace tickets and whatnot, right? So you are not no longer jumping over one tool to another just to say that, hey, I am seeing one issue on the Datadog side. Let me see what is happening on my App Dynamics side versus what is happening on my ServiceNow side. So you get a singular platform in which you are seeing everything here. Now, after you have ingested the data, and you can do slicing and dicing of the filtering, user filtering, right? You want to slice and dice based on the assignment group or based on the date range and whatnot. After you have ingested the data, what you want to do is you want to see the how the AIOps fun begins. So to see the AIOps fun, what you have is you have these two sections here. So let me go through the dynamic CMDB first to just to set the perspective here. So if you take a look here, what we do is we connect to your CMDB and then we start ingesting the data here. Now, the moment we ingest that data, a couple of things you will see upfront here that, hey, every CI which we ingest, based on the model runs, we identify the outage probability and a score of it. Do not get confused by 100% because I make this VM out of space every third day. So that's how the system is giving me 100% outage probability. But if there are specific services, you will know which services are healthy, which services are not healthy, which services have high outage probability versus low outage probability. And the same is true for systems and business services as well, right? So if you take a look at this DevOps onboarding portal business service here, what we also do is we have these CI connections here, which help us identifying and predicting issues. So we know that, hey, your A0 private dev is connected to my Aisera sample Spring Boot application, which in turn is connected to my Azure demo application, right? So and these can be different CIs. So we are not looking only from a single ticket perspective versus single alert perspective. We want to take it look at things from a holistic perspective where there are CI relations which are happening. You can see the tickets over time that, hey, how the CI has fared, how many tickets it had in February versus March versus April, right? And then you have the scores and the outage probability that, hey, in February I had the score 10, but in April this business service was a lot more stable. So this gives you a pattern analysis for your CIs and business services, which can give you enough context, right? That, hey, which are the business services which I need to focus more versus less, and you get all kind of facilities here. Having said that, so now we understand that we have the CIs, we have the relationship, we have the outage probabilities and the scores attached to it. So how do we connect all that? For that, we have our AI observability platform in which we have the major incidents here. Now, these major incidents are the result of our AI ops pipeline, which we process. These are the early detections which we identify. This is where all the magic is happening. So I'm just going to take a small example of this AMI. So whenever I say AMI, this is Aisera major issue. Uh, so if I look at this AMI is essentially telling me that for this specific VM, the disk usage was approaching 80% here. Now, in ideal scenario, you can get it from Splunk itself, right? So, or any monitoring tool, what value addition Aisera is doing. Now, look at the right side of the story here. wherein what we are saying is that what the system identified depending on the data is that, hey, there was a change request which was happening, which changed your log rotation policy or anything else. And because of this change, when the log rotation happened on 18th March, uh, we started seeing a lot of alerts coming in from your Datadog side. So if you take a look here, we saw that 2785 and we talked about the Datadog here. So as soon as this change request was implemented, this is the creation date, the implementation date might happen a bit later. But as soon as this change was implemented, we started seeing a lot of alerts which started happening on the temp disk size, right? And the system captured all that alert and correlated your change request with this specific alert. Uh, Let me give you another example of it, right? So let's take a look at this example here, wherein this is a lot more enriched here, wherein there was an impact of the recent database change. Something happened on the database side, right? So we captured, hey, what change happened on your database side, and when that change was implemented, what were the observability alerts which came into the picture? What were the incidents which were filed after this, right? So you are no longer looking at uh, only alerts, only incidents, only logs. What we are helping you to give you a full 360-degree picture wherein you can correlate all those things together. So you are no longer responding to specific alerts. You actually know that, hey, there was a change which was implemented. Because of that, these alerts came, and because of these alerts, some users filed ServiceNow incidents. On the top of it, what exactly happened is that the system, because we are hooked into your CMDB as well, we identify which all business services got impacted, which all systems were impacted, which database was impacted, right? And all those kind of things, which application layer was impacted. So, saying that again, you are no longer responding to a single event, to single alert. You are looking at an issue from a 360-degree view from the correlation perspective of it. Now let's come to the left hand side of it, right? So the first field is very, very important here, wherein you have a status here. So one of the things which where we differentiate ourselves from the from other product is that we are not a rule based system. What that means is that there are machine learning algorithms which take decisions in the back end, and if you receive those decisions and if you receive those AMIs, you can provide feedback to those AMIs, right? That, hey, this is not a major incident. This was probably a development database server which was impacted, and I see that this is not a major incident. Or you can say that, yes, this caused me an outage. So you want to accept it and you give it back to the system, pat in the back to the system, and the system will learn from it. And next time, if the system identifies the same pattern, the system will bump up the score more often, and the system will give you a lot faster early warnings because it knows that you have given a positive feedback to the previous incidents. Or you can simply say that, hey, I don't even want to see this. This is some garbage which you have produced. Do not even create these kind of major incidents. So the feedback learning mechanism helps us reduce these manual if then else loop wherein you want to get a report whenever your CPU utilization is greater than 75%. Those timelines or uh, those parameters become dynamic for that sake. Going further, you have the stage of an AMI wherein you can identify that, hey, is this an early detection stage versus has the outage already happened? What is the outage probability of it? We also attach the assignment groups to it, right? So who do we want to report in case this happens? So the impact assessment of the recent database change, the system identified that, hey, they should go to security. I don't know why. Maybe something happened in the change request, but that's what the system told me. Uh, then, if we go further, you have the summary of the incident, right? So rather than looking at one after another, you can say that, hey, okay, how many alerts were there versus how many historical similar incidents I have seen in the past versus how many configuration items and all that, right? Then going further, what happens is the system identifies and gives you a major incident timeline. Then, hey, when did we receive the first alert? Uh, when this was the early warning versus when did we actually identify that, hey, this has crossed the threshold or this has crossed the defined baseline, and only when we cross the system crosses that baseline, that's when we detect it and give you an early notification. So you are no longer reporting to every alert which is happening in the system. You are responding to very, very curated machine learning and AI based decisions, and they will identify you. So reduces the noise here. And then there are multiple stages, right? So you can have, if you don't address it here, you can have degraded performance, or you can have service outages. Those multiple people have filed critical incidents, or suddenly you have started seeing flood of alerts. So the system identifies those kind of patterns and give you a holistic view of where exactly things are happening. Going further, the system also identifies the root cause of it. That, hey, I saw something happening on my database side. So the system gives you a a front seat to identify or troubleshoot your issues, right? You are no longer blind to look at the history of an incident versus what alert were caused. The system is giving you upfront root cause analysis, and it helps you. It might not be 100% accurate, but 100% efficient, not accurate. You might need more information, but that's where the things are. Going further, I talked about the dynamic CMDB part of it, right? So there is a causality which happens in the system wherein you identify how many tickets were happening on the this specific user based database CIs versus how many tickets happened on other CIs, and the system correlates all this and provides you. So essentially, what this graph is telling me that, hey, one ticket happened on this CI versus one ticket happened on this CI. This can be alert or incident or change request, which we can identify. But what the system is telling me that, hey, because of all these actions on all these changes, the it resulted in 50 tickets on another CI. So that way, whenever you are starting to troubleshoot, you already have all the context you need to troubleshoot an issue. Uh, Going further, we already talked about the connectivity graphs here, but I want to talk about these three concepts wherein you have deterministic relationships which are coming from your CMDB pipeline, where we ingest your baseline relationships. On the top of it, the system creates the probabilistic relationships, which the patterns which the system has seen, and those patterns will enrich the system data. Uh, and on the top of it, you have the added by agent as well. This is your system. So you know better than anybody else that, hey, this Aisera user database is also connected to my AOD reporting. So you can always go ahead and connect these relationships, and these relationship can become your manual relationship or agent relationships. And next time, if you take a look here, what it did is the moment you connected your Aisera user database with EOD reporting, it automatically connected to an AutoSys server and some other job, right? So that way, the system connects the dots between different systems and help you give you early predictions and other things. Last couple of things here. The system, we already talked about it, right? So every AMI will have tickets over time. It will tell you, if you take a look at the blue line, it is the change request, when was change filed, when did you see the first alert, when did you see incident, and how exactly it fared, right? So it talks about all that. And then comes the predictability and the identification of the outages part of it, right? So same thing here. If you take a look up here, we said that, hey, we received an early warning and then I said I detected it. The same can be quantified into maths as well, right? So when you we started receiving the tickets, the score was low as 2 on a scale of 10. And as and when we started seeing that, hey, this has crossed a specific trained baseline, that's when we started bumping up the score. And that's when Isira said that, hey, we are seeing some anomaly in the system. You better go have a look at it. The same is with the outage probability as well, but this is more from a historical perspective as well, that, hey, historically, how has this pattern behaved? Has it caused an incident before as well? In this case, upfront, it started saying that, hey, there is an outage probability of 95% that this kind of issue can cause issue, because we have seen this in the past as well. And then some mathematics behind it, that if you provide feedback, how do we evaluate it, and those other things. The last thing which I want to talk about is the major incident detection lineage. This is where some of the machine learning concepts come into picture. That when we get the data, we train our models based on your data. So the gray lines which you are seeing is the baseline on which we have seen the data and on which the model has been trained. So as soon as this baseline gets breached, that's when the system starts identifying that, hey, something odd is happening. I haven't seen this pattern before. So let's start getting addressing that. So that way, it gives you a lot of context about a single issue, which will help you resolve these things in real time.
Jayant, if you don't mind, I'll take it over from here if you don't. Usually, how a Sarah evaluation works, right? We normally begin with a tailored demo, right? Noticed a few people, they asked me to find time with them directly. So what I normally do is I'm going to drop my email address down here in the chat for everyone. Feel free to either grab time with me directly, right? Send me an email, or I'll pass you off to your main point of contact. We're going to begin showing some similar use cases to customers to your size and suit. We want to make sure that's as relevant as possible. We'll share customer stories and hopefully understand, what you guys have done to date with AI. We can perform some sort of ticket learning or exercise around your incidents. We ingest a part of your tickets or those incidents, and we can show an applicable and predictable model of what we understand to the state. This intent will help us with understanding user behavior and help you with most relevant use cases and where you can really get started, whether it's like a password reset, provisioning, etc. And then we have a purpose-built BVA and ROI. It's been battle tested a few hundred times to assist with every evaluation. As well, that said, Kay, Jayant, thank you so much for joining us today. It's really great to see new faces and a reminder of face on here today. Joanna, always appreciate seeing you, and thank you so much for running this with me. If you guys need anything, please reach out directly, and thank you for joining us here.